Okay, so this is version 2 of the quiz. So first problem, right? So we're trying to prove that triangle RUV and triangle STV are congruent. Okay, we're trying to show that they have the same dimensions, the same size and shape. Okay, so we start with the process we always have. So our first step in the process is to write the given. So we have steps and we have justifications. Okay, in our process, we want to write our givens first. So our givens this time come from the diagram. They're not coming from written words, they're coming from the diagram itself. So we can see we have a hash mark here between S and V and between V and R. Okay, so that's telling us segment SV is congruent to segment RV. So given. Okay, the other thing they're giving us is they're showing us that angle TSV and angle URV are right angles. So for our second given, we're going to say that angle TSV and angle URV are right angles. Okay. Don't write angle TSV and angle URV and then just leave it. Okay, this should be an explanation. These are the steps and the justifications. It should not just say angle TSV and angle URV. Some of you on the quiz just wrote angle TSV and angle URV. You have to explain what the step is. And we're saying that they are right angles because of the diagram. So these givens could also say diagram. Also make sure when you write sides for your triangle, you're putting the bar over the names, the segment. Segment SV and segment VR. Sides of a triangle are segments. Okay, and angles, again, we name angles with the angle symbol. Okay, you can't just write TSV and URV. It's angle TSV and angle URV are right angles. So step 1 in the process, write the givens, we're done. Okay, step 2, look for shared sides and vertical angles. We don't have any shared sides, but we do have vertical angles. So angle TVS is going to be congruent to angle UVR, okay, by the vertical angle theorem. Right? The vertical angle theorem says vertical angles are congruent. We could even add a step before that says angle TVS and angle UVR are vertical angles by the definition of vertical angles, and then say that they're congruent by the vertical angle theorem. But for simplicity's sake, we can tell they're vertical angles, so we can go straight to they are congruent by the vertical angle theorem. Okay, vertical angles are always congruent. All right, so that's step 2. So step 1, write the givens. Step 2, look for shared sides of vertical angles. Step 3, we're going to use the givens. All right, again, our goal is to find 3 corresponding parts that are congruent. So far, we have 2 corresponding parts that are congruent, a side and an angle. We're going to find the last one using the givens. So step 3 in our process is use the givens. If you have not used a given in your proof, it's not to say you have to use your givens, but if you haven't used them for our purposes, you probably haven't done it right. You probably have to use all of your givens for the proofs that we're going to give you. Okay, so if we know we have right angles, on your reference sheet, there's the right angle theorem. Okay, we use this theorem over and over again. If you have right angles, you know by the right angle theorem that right angles are congruent. So we have right angles by the right angle theorem. We know right angles are congruent. Therefore, we can say angle TSV is congruent to angle URV. Okay, we know right angles are congruent. Okay, and then our last step is to show that the triangles are congruent using one of our postulates. Okay, again, cover up one of the triangles. Just look at one triangle. Is this an angle or a side? This is an angle. Angle or side? It's a side. Angle or side? It is an angle. Okay, so by the angle side angle postulate, again, on your reference sheet, it tells you if we have two pairs of congruent angles and the included side are congruent, then our triangles are going to be congruent. So triangle RUV is congruent to triangle STV. Okay, we know the triangles are congruent because we have found two angles that are congruent and the included side that's congruent. So we can use the angle side angle postulate to show the triangles are congruent. So again, to summarize again, we wrote the givens. We had two givens coming from the diagram, and we wrote them down. Okay, SU, SV, and RV are congruent because of the hash mark that's showed in the diagram. It also showed us that angle TSV and angle URV are right angles. So that's given. Step 2 in our process, look for vertical angles with shared sides. We had vertical angles. We know vertical angles are always congruent by the vertical angle theorem. So we know angle TVS and angle UVR are congruent. Again, V is the vertex, so V must be in the middle when we name our angles. UVR and TVS. So write the givens, look for shared sides of vertical angles. Step 3 in the process, use the givens. So our first given already has a congruent sign, so there's nothing more we can do with this. Okay, and our goal is to get 3 congruent pieces. So we have 1, 2. We're using our other given here. Okay, what do we know about right angles? We know right angles are always congruent by the right angle theorem. And then we have angle side angle. Again, always draw in the marks in your diagram so you know what you're dealing with. You know what you have written down, and it makes it really easy to determine what postulate you're going to use to prove the triangles are congruent. You just go in order. Okay. So that's number 1. Okay. Number 2. Okay, this was also number 1 on the first version. So I made this problem separate. So if you go back and look at the first video for the first version, it'll have this question solved out. So in this video, we're going to skip the second one. Okay, and go on to the third and the fourth. So this one is on the other version. It was number 1 on the other version, so it's on the first video for that version. Okay. So third one. Okay, we have steps and justification. Is it all in there? Yes. Okay, steps. Okay. Step 1 in our process is to write the givens. We have 2 givens. WX is parallel to YZ, and WX is congruent to YZ. Let's make sure it's on our diagram, and it is. We have hash marks for YX is congruent to YZ, or WX is congruent to YZ. And then we also have this little arrow showing us that WX and ZY are parallel. Okay, and these were given. Step 1 in the process, write the given. Step 2 in the process is to look for shared sides of vertical angles. We notice we do have a shared side. Okay. XZ. So we know XZ is congruent to XZ by the reflexive property. You could have also said XZ is congruent to ZX by the symmetric property. That's probably a more accurate thing to say, because if you flip this triangle around, it's actually going the other way. So it's probably more accurate to say xz is congruent to zx by the symmetric property. But our reference sheet only has the reflexive property listed on it. So for simplicity, we're just going to stick with reflexive for our purposes. Just stick with reflexive and you won't go wrong. So xz is congruent to xz. Okay, so step one, write the givens. Step two, look for shared sides or vertical angles. We have a shared side, we don't have vertical angles. Okay, step three, use the givens. So let's go to our first given here. We have parallel lines. Okay, you guys should know when we have parallel lines, we are looking for alternate interior angles. Here's our two parallel lines. Okay, so our alternate interior angles are going to be here. Angle WXZ is congruent to angle YZX. That is by the alternate interior angle theorem. The alternate interior angle theorem tells us if we have parallel lines, then the alternate interior angles are going to be congruent. So we have parallel lines, so our alternate interior angles, WXC and angle YZX, are going to be congruent. Again, this is coming straight from the reference sheet. It should logically follow. Every step should logically follow from what is given or what we know about definitions or postulates. Okay, a lot of you on the quiz said these were congruent, angle WZX and angle YXZ, because of the alternate interior angle theorem. But in order for those to be congruent, they're definitely alternate interior angles. But in order, the alternate interior angle theorem says if the lines are parallel, then the angles are congruent. Okay, so that would require XY and YZ to be parallel. And there's nothing here telling us that XZ or WZ and XY are parallel. There's nothing here telling us these two lines are parallel. Therefore, we can't say the alternate interior angles are congruent. If we got to add in our lines. So for reflexive, we add in our dashes here. It should look like this. Okay. Our other given we have, it's already a congruent sign. So there's nothing more we can do there. We've reached the end of the road for that one. So again, we followed that process. We wrote the givens, looked for shared sides or vertical angles, and used the given. And based on that, we now have three pieces that are congruent. Okay, two sides and an angle. So again, cover up one of the triangles. Okay, and we have side or angle. That's a side. That's an angle. That's a side. We have side, angle, side postulate. The side, angle, side postulate tells us if we have two pairs of congruent sides and the included angles are also congruent, then the triangles are going to be congruent. So we can conclude that triangle WXZ is congruent to triangle YZX. Wrote the givens, shared side or vertical angle. We had a shared side. We used the givens, parallel lines, telling us we should use the alternate interior angle theorem. Almost every time you get parallel lines, you're going to want to use alternate interior angles on these proofs. Okay, we have three congruent corresponding parts. They turn out to be in the order of side, angle, side. So we use side, angle, side to show that the two triangles are congruent. I think we're good on that one. Okay, number 4. We had a lot of trouble on the bisector part of number 4. So we'll try to straighten that out. And this one we have givens coming from the words, and we have givens coming from the diagram. So the words tell us one given, which is that GJ bisects angle HGI. So this is an angle bisector, not a segment bisector. It bisects an angle, so it is an angle bisector. And the other given we have, again, we have hash marks here. So HG is congruent to IG. This is given by the diagram. You just have to write given. I'm putting diagram there just so you know that this is coming from the diagram. So step 1 in the process, write the givens. We've done that. Step 2 in the process, look for shared sides or vertical angles. We have a shared side. Both triangles share the side JG. So JG is congruent to JG. This is our reflexive property of congruence. JG is congruent to itself. But if you look in the mirror, you see yourself, you're congruent to yourself. You could have also said JG is congruent to GJ, but then you would have to have put symmetric property. Okay, in this case, it's better to use reflexive because they're going in the same direction. But I would accept either one. So we've written the givens. We've looked for shared sides or vertical angles. Step 3 in the process, use your givens. So let's use our first given. JG is a bisector of angle HGI. So we know right off the bat we're using the definition of an angle bisector. And if you look at your reference sheet, an angle bisector splits the angle in half. It splits it into 2 congruent angles. So for bisecting HGI, angle HGI, which it says, that means we're splitting it into 2 congruent angles. So all we have to do is name those angles, and we know they're congruent by the definition. So angle HGJ is congruent to angle IGJ. Okay, a lot of you are trying to make up midpoints here. You can't say that we have midpoints because we don't know it's a midpoint. Okay, because we don't know the triangles are congruent. If we knew the triangles were congruent, then we would know that J is the midpoint because we know HJ would be congruent to JI. But we don't know that. We can't just make it up. We have to use what is given. And again, when you're naming these angles, G is the vertex, so it has to be in the middle. HGJ and IGJ. Okay, last step. Well, first, how many congruent parts do we have? We have 3. Okay, we've used our givens, right? Can't use our second given. It's already got congruent parts, so it can't do any more with that. So we're on our last step. Cover one of the triangles and look at one. Side or angle, that's a side. Side or angle, that's an angle. Side or angle, that's a side. So the side angle side postulate tells us if you have 2 pairs of congruent sides and the included angle is congruent, the included angles are congruent, then the triangles are going to be congruent. So triangle GHI, GHJ is congruent to triangle GI, GIJ. Okay, so step 1, write the givens. One given comes from the words. The other given comes from the diagram. But we have 2 givens. After we write the givens, we're looking for shared sides or vertical angles. We have a shared side, JG. Okay. Step 3 in the process is use the givens. Right? They're not going to give us a given that we're not going to use. Okay, I'm telling you that right now. We're not going to have a given that you're not using. So if you didn't use your given, or the given doesn't have a congruent part in it, then you haven't done it correctly. Because you're going to use your given. So since we have a bisector, we know that 2 angles are good. That the angle that gets bisected into 2 congruent angles, HGJ and IGJ. So those are congruent. We have 3 congruent parts, 2 sides, right? This is a side, that's a side, and that's an angle. So we better have 2 sides here and 1 angle here, and we do. And that side angle side postulate tells us that the triangles are congruent. Okay, again, if you want to look at number two is on the other video. So I would recommend doing that.